information we learned last day about the tangent ratio to actually now calculate lengths in a triangle. As a prerequisite skill, you need to actually be able to solve for x in all four of these cases. These are all ratios, and if you look at the first one, you might be thinking, oh, I know, I see. 5 times 6 gives you 30. So I better do the same thing to the top to give me the other number. 2 times 6, of course, is 12. Correct. So if you see that nice numbers, you can quickly find the factor. Beautiful, it's done. But in part B, it might be very difficult to say what times 3 gives you 7. I know you can with a fraction, though. Most people hate fractions. So there is another method that maybe you've learned before that I'd like to review with you. It's called cross multiplication. And this is where you take the numerator on the left and multiply it by the denominator on the right. And that's equivalent to the denominator on the left multiplied by the numerator on the right. Now, there is a mathematical valid reason for this, but I'm not going to show you this now. If you do want to find out, come find me in class. But if we do cross multiplication, I'm going to take the 3 and multiply that by the 15, and that's equal to the 7 multiplied by the x. 3 times 15, of course, is 45. And then now we just need to divide by 7. So yes, your answer is a fraction. Don't be afraid of fractions. Okay? For something like C, you're like, there is no fraction on the left-hand side. Well, there is now. If you divide this by 1, that's still a fraction. So now you can cross multiply. 0.5 times 27 equals to 1x. 0.5 times 27 is just 13.5. There's your x. Yay! Same thing with this one now. I'll leave you to try this. .25x equals to 1 times 9, which is 9. This time I'm going to have to divide by 0.25, and yeah, that's the answer of 36. Cool. So knowing this prerequisite skill, I hope you can combine this now with what we learned last class. So as a review from last class, remember we had this angle theta, and then we said that this was the opposite side, and this was the adjacent side, and this was the hypotenuse side. Well, from last class we found that the ratio comparing the length of the opposite side to the length of the adjacent side does not depend on how large or small the triangle is, but it actually only depends on the measure of the angle. So the tangent ratio was equal to the length of the opposite divided by the length of the adjacent, or op over adjacent equals tangent theta. So today my questions are going to be like this. What would be the height of a right triangle that has a base of 1 centimeter and its angle of inclination is 60 degrees? So if I were to draw a picture, I'm saying, look, I've got a triangle here. I should draw something that's more more correct. 60 degrees. This base is 1 centimeter long, and the question is, what is the height? Well, we can do this by, you're right, using the tangent ratio. So tangent 60 is equal to h over 1. And that's nice because h over 1 is just h. So now what's tangent 60? You can go to your calculator, turn on calculator, and then just type in tangent 60. Boom, 1.73. And in this case, centimeters. Okay. Remember, 60 degrees. So make sure your calculator is in degree mode. Okay. I'm going to ask you to try example number 1 now. Find the length of x. So if I have this target angle here at 36, I notice that the side across from that must be the opposite. The side adjacent to it must be the adjacent. And lo and behold, I should be able to write out the tangent ratio again. Tangent 36 degrees this time equals to opposite, which is x, over adjacent, which is 78. Once again, we'll do that cross multiplying thing. So 1 times x is just x, and then 78 times tangent 36. What's that? I don't know either, but this is where it's great to have a calculator. 78 times tangent 36. Bam! 56.67. Cool. 56.7 centimeters, and that is equal to the opposite side. Alright, let's turn the page. Hey, can you find the length of y this time? Well, same idea. Look at this. Opposite side. Look at this. The adjacent side. Look at this. The tangent ratio. Opposite, 83 over adjacent, which is y. This time now you have to solve for y. Notice it's in the denominator. So we could do the cross multiplying thing again. Y times tangent 19 degrees equals to 83. And if I want to solve for y, I'll take 83, dividing that by tangent 19 degrees. And once again, calculator time. 83 divided by tangent 19. Close the bracket. Bam. Wow. 241 centimeters. There you go. Okay. So that's the basic skill. Now I'd like to see if you can apply it to different word problems. We've got two of them here today. So the first one, yeah, I'm actually 1.7 meters tall. I went to measure the height of the Burnaby South flagpole yesterday, and I stood 18 meters away from that pole. So if here's the flag, here's me, I'm 18 meters away. The angle of elevation from his eyes to the top of the pole, so that's from here to the top of the pole, along the horizontal, was 18 degrees. Oh, sorry, 32 degrees, my fault. Find the height of the flagpole. So I want this entire height here. But if I look at the triangle that I have, I can only find this particular portion. But that's okay. Let me try to find that first. Okay, so I'm going to find x first. And to do that, I'm going to use my tangent ratio. Tangent 32 degrees equals to opposite. And what is opposite in this case? Yes, it's the x over adjacent. What's the adjacent in this case? You got it, 18. So we'll cross multiply again. 18 times tangent 32 degrees equals to 1 times x. Calculator time. 18 times tangent 32. What do we get? What do we get? 11.25. So x equals 11.25. Now that's great, but that's not the actual height. The height is that x value here plus what though? Plus, oh yeah, plus the height of me, Mr. Lee's height. Because I didn't measure this from the ground. My eyes aren't where my toes are. So I have to add that together with my x value, and then I can get the correct answer, which is, what's 11.25 plus 1.7? That's what, 12.95. And that's how high the flagpole is at the school. Ta-da! Okay. Last but not least. For a wheelchair ramp to be considered safe, says the ratio of the vertical distance to the horizontal distance of the ramp needs to be less than this ratio of 1 to 10. So the question is, would a ramp with an angle of inclination of 5 degrees and a vertical distance of 1.2 be considered a safe ramp? I'm going to draw a picture of this ramp. It's pretty flat probably, right? 5 degrees. 5 degrees here. Vertical distance of 1.2 meters. I guess the question is, what is the height? Because once I have that, I can compare it to this ratio of 1 to 10, because the 1 represents the height and the 10 represents the base, right? As long as my ratio is less than that, I know it's safe. If it's more than that, it's not safe. So how do I calculate the height then? Well, tangent 5 degrees. That, of course, equals to height divided by 1.2. We've done this so many times that I hope it's pretty straightforward to you now. Doing it on the calculator, 1.2 times tangent 5, 0.105. Okay, that's our height. Okay, so now the ratio, right, of height to base, in this case, is 0.105 to 1.2, or written as a fraction, I'll put 0.105 divided by 1.2. And if I did that on the calculator, 0.105 divided by 1.2, I'll get, 0.0875. And the question is this less than or equal to 1 over 10, or 1/10? Well, the ratio here is 1/10, right? 1 over 10. I think this is definitely less than 1 over 10. So, yes, it is safe. There you go. All right. Now, I hope it's safe for you to try these questions. All right. See you for the next video.